Hi everyone, good evening, welcome back. Hello, good evening. Quickly let me know in the chat box if I am clearly audible and visible. Hello, be quick. Alright. Good evening Nalini, good evening Sandhya. Great, great. Also let me know your name, Also let me know your name. Very good evening. Let's start units and dimension. In this one class, we are going to complete the entire chapter and we will solve portions as well. Bilkul, yes, absolutely. You can study from one shot lectures for your NEET exam. All right, Yash. Okay. Good evening, Aditi. Good evening. Good evening, Puneet. Puneet, okay, fine. Hi. All right. I'm audible, right? So let's begin. First, in units and dimension, we are going to complete the units part. I'm going to give you some concise notes. We are going to discuss everything related with dimensions, and then we'll also try to cover errors and measurement in today's class. All right, let's begin. Let's quickly begin, my dear friends. Let's start with units. Good evening, good evening. As you guys can see, first of all, we are going to discuss fundamental quantities. We are not going to invest a lot of time in this particular topic. As you all know, what are fundamental quantities? We actually categorize quantity in two parts. One is fundamental quantities, another quantities are known as derived quantities. So among thousands of quantities, we have got we have chosen 7 as fundamental quantities. The reason for this is not based on any concept. We have randomly selected these are mass, length, time, temperature, electric current, amount of substance and luminous intensity. Along with their names, you can also remember, obviously you know their SI units: kilogram, meter, second, Kelvin, ampere, mole or cadsense, right? So this will be denoted by m, l, t, theta, I and j. So amount of substance will be denoted by mole only. And we can also remember the CGS units of these. So this is very easy. That's why I'm not writing any of these things down in one shot lectures. We will simply waste our time. The important part is, we have got also some units that are called as some supplementary units or supplementary physical quantities. In this, we are going to talk about angle and solid angle, my dear friends. Kindly remember these. When we are going to talk about angle or solid angle, they do have unit, right? So kindly remember that they have unit but are dimensionless, right? So any student who's part of Yakeen NEET English batch, let me tell you, we have covered all of these things in your live lectures and I'm giving you new notes, right? So these are new notes for you. Pretty concise, but everything will get covered through these notes. And then you have got angle. SI unit is going to be radian. SI unit for solid angle is going to be steradian. Solid angle is nothing but a 3D angle. You can also understand it as 3D angle, right? Formula for this is area divided by r square. For angle, it is arc length divided by r. Got it? Arc length divided by r. Dimensions of mole, you can simply write it as mole itself. right? Sorry, dimensions of mole, I mean to say symbol can be written as more. It won't have any dimensions because again it is given mass divided by molecular mass, right? So you won't be getting any dimensions out of amount of substance. It's simply a number, 1 mole, 2 mole, 3 mole, correct? So some other derived physical quantities, we have got numerous of physical quantities, all other than these 7 fundamental quantities. Every physical quantity is a derived physical quantity, like for example as force, work, and we have got SI unit of this Newton. So these are simply some examples, nothing so important. Kindly remember these 2 points about angle and solid angle, that they have unit but are dimensionless. Got it? Clear? Done? Any other doubt? Clear? Moving on, my dear friends, this page is very, very important for you. All right. See, if we are going to talk about each point over here, it will take a lot of time. So I have got everything written on this one page, and you can expect at least 1 or at max 2 questions from this one single page. See, we have got we can actually remember n number of dimensional formulas. Out of them, what I want is, I want you to mug up, I want you to really remember these dimensional formulas of these physical quantities, because according to me these are very, very important. For example, as force, we are going to use force a lot. Then work, energy or torque, all will have same dimensional formula, m1 L2 T minus 2, right? For pressure, stress and Young's modulus, again all 3 will share same dimensional formula, that is m1 L minus T minus 2. Again, my dear friends, gravitational constant, we can derive it, but in your exams you will save a lot of time if you will simply remember these formulas. It is m minus 1 L3 T minus 2. Planck's constant is one of the is again one of the formula, and let me tell you, if anyone has doubt in Planck's constant, we are going to use E equals to hc by lambda or h times nu, where this is frequency, this is energy. We already know the dimensional formula for energy. For frequency it would be T minus 1. So you can find out for h, and it comes out to be m1 L2 T minus 1, right? These are important dimensional formula. Again, for epsilon naught, that is permittivity of free space and permeability of free space, epsilon naught and mu naught are also important. Please remember it. You are going to get all of these things, this entire PDF, these entire notes through WhatsApp channel. Okay, so don't worry about it right now. Pay attention. Clear? Done? Very, very good afternoon to all of you. Not good afternoon, good evening. Okay, good evening. So let's now come back again. Gas constant, slightly important, but if you are going to ask me amongst these, which dimensional formula are most important, so everyone will remember for force, work, pressure, stress. Kindly remember it for gravitational constant, epsilon naught and mu naught. We are going to use them extensively in the questions related with relationship between physical quantities. In past few years, NTA has directly asked question related with capital G, epsilon naught and mu naught. Clear? Besides this, let me also tell you, if you want to derive a dimensional formula, how you can do it. For example, as coefficient of viscosity. Now you must remember at least the formula. So coefficient of viscosity is eta. Please remember the formula is 6 pi eta RV. My dear friends, you can also remember the another formula, that is viscous force. This is viscous force is equals to negative times of eta A dV by dx. This is known as force. Even if it is viscous force, for us it is force. We know the dimensional formula of force. This is area, and this entire thing is known as velocity gradient. Velocity gradient. We are going to use this term also quite often, that is gradient with the suffix gradient, right? So velocity gradient, pressure gradient, potential gradient. So whenever they are going to talk about something gradient, you are going to write that thing, like for example as pressure gradient. So you can write it as dP by dr or dx. Got it? So in x basically is length, pressure, P is pressure. So dP by dr is pressure gradient. Got it? So we can also derive the dimensional formula of eta from this formula, or you can use another formula, that is 6 pi eta RV. 6 pi eta R into V. My dear friends, this formula is only applicable for what? For spherical bodies. But point is, formula is accurate, na? No matter whether it is true only for spherical bodies, it is not true for any other bodies. That's not the point. The point is, this formula is dimensionally correct. So if I want to find out the dimensional formula of eta, I can simply write down the dimensional formula of force divided by pi is dimensionless divided by dimensional formula of radius multiplied by dimensional formula of velocity. Correct? So we can find out the dimensional formula of eta. That's what we have done over here, and we are going to get to our answer. Hopefully this is all clear. Done? Any more doubt, my dear friends? Moving on, then the next is Stephens-Boltzmann's constant, that is sigma. Or now you can remember this as dq by dt, that is rate at which energy is, this is basically rate of energy, right? Power. So this will be in watt. Sigma E A into T raised to the power 4. T is temperature, A is area, E is emissivity. This will be dimensionless. So again we can find out the dimension of this sigma. Kindly note it down, right? And as I have told you, in coefficient of viscosity we were talking about velocity gradient. Again we have got potential gradient and velocity gradient. So here you have got potential, this is dx, here you have got velocity, this is dx. So these are going to be the dimensional formula of all of these things. If you have got any doubt, you can let me know. I'm going to derive it for you, but I believe everyone can actually derive the dimensional formula of potential by themselves. Current is a dimensional constant. Do remember the dimensional formula of resistance as well, right? Do remember it for resistance as well. And for potential, my dear friends, if any one of you have any doubt in potential, kindly don't use V equals to IR, because for that you will have to remember for R as well, use potential is equals to work done per unit charge. Got it? And we know charge can be again written as current times time, current multiplied by times, and then using this you can find out the dimensional formula of resistance. But this is what my point is. Please derive it only once and then try to remember it. Clear? So this table is all good. This table is all good. Now let's come back to the third table. In third table, what we are seeing is, we are seeing dimensionless quantities. All angles, all trigonometric ratios are dimensionless. Clear? Because angles are nothing but arc length divided by radius. Length, arc length is a length, radius is also a length. So length divided by length, dimensions gets cancels out. All trigonometric ratios, whether you are going to talk about sine theta, cos theta, tan theta, perpendicular upon hypotenuse, base upon hypotenuse, perpendicular upon base, basically we are talking about length divided by length. So anyhow, all trigonometric ratios will come out to be dimensionless. E raised to the power x is also a dimensionless quantity, and this x is also dimensionless. Kindly note it down. So we actually use it in when we are actually talk about capacitance, we talk about RC circuit, we write something like e raised to the power minus t divided by tau. So in this tau is the dimensions of this tau is in seconds, so that e raised to the power whole thing becomes dimensionless quantity. Let me again explain this to you. Let's suppose someone writes down e raised to the power a divided by force, and f is, let's suppose, force. So this means that a will also have the dimensions of same that of f. Whatever f is, let's suppose f is force, so a will also have the dimensions of force, because this whole thing should be dimensionless and this thing should be also dimensionless. Clear? We are going to use it now. Let me give you one or two examples, nice examples. Let's start with this. All the students who are part of the batch, don't worry, I'll try my best that I'll also give you some new question. Like for example, as this is a new question, I don't think so we have done this in class. I'm starting the timer for you. 90 seconds. Let's start. The force F is given in terms of time t and displacement x by the equation. The main concept over here is we are going to use two concepts. One is principle of homogeneity. What do you mean by principle of homogeneity? It basically means that if we know that F is a force, so this thing, this A times cos of Bx, this whole thing will also be a force, plus C sine D times T, this entire thing will also be a force, right? And now the main point is this Bx must be dimensionless. This Bx and this dt must be dimensionless. Why? Because these are nothing but angles. I mean, what you are going to put inside sine or cos? Angles, right? And just now we have discussed that angles are, pole is not coming. I mean, pole will not come, buddy. Just write down in your chat box, just write down answer in the chat box. Pole will take the answer. Okay, got it? That's how pole is going to work. So these are nothing but these are angles. Done. So what I am trying to say is that fine, it is a we also need to know principle of homogeneity, but right now if you are going to closely see, this is dimensionless, this is dimensionless. It means that B multiplied by X is a dimensionless quantity. And for dimensionless, I mean to say that M will be 0, L will be 0, T will be 0, and anything, any base quantity will be raised to the power 0. Got it? So this means that B will have the dimensions of 1 upon X. That means L minus 1. B will have the dimensions of L minus 1. And then again D, T will be dimensionless. N0, L0, T0. This means that D will have the dimensions of 1 upon T. So that it could get cancelled out, right? So that means this is T raised to the power minus 1. Now they are saying find out D upon B. They are talking about find out D upon B. D upon B, dimensions of this, right? Dimensions of D is T minus 1. Dimension of B is L minus 1. So this means that this is L1 T minus 1. L1 T minus 1. L1 T minus 1, and there is no M. So M0 L1 T minus 1. My dear friends, kindly note it down. Most of you are saying 1 or 2. Most of you are saying 1 or 2. Please see, the answer is going to be 4. The answer is going to be 4, my dear friends. All the students who are saying it's going to be 1, they are talking about dimensions of D and B. Got it? And X is displacement. I can explain it again, don't worry, but please ask your doubt. 4th is correct according to me. Only 33.33% of you have got it correct. So according to you, there will be no length. It is not possible, no? It is not possible. Got it? Your teaching method is too. Thank you so much. Come on. Any doubt? We have not done this question in our Yakeen NEET English batch. Why not? We have done numerous of similar type of problems, but I thought let me bring you some new questions, right? So this is a new problem. 4th is the correct answer. Kindly note it down. What I have used. Now please see, one major problem many students faces ki there is a gap between theory and numericals. When we are learning theory, everything is going good, but as soon as we actually pick up numericals, we face the problem. So the point is that there is a gap between your understanding of theory. You might be learning the theory similar to what you actually apply in chemistry or biology. There is a difference. So whenever you are reading a point in physics, instantly talk to yourself, what are the physical implications of this? What are the applications of this, right? So if someone is saying all trigonometric ratios are dimensionless, all angles are dimensionless, this means that when we are going to talk about something like this Bx makes up the angle. So this is dimensionless. So how come this will be dimensionless? When B will have the same dimensions of 1 upon X, so that it can cancel out. Got it? How come dt will become dimensionless when d will have the same dimensions of 1 upon t, so that t and t can get cancelled out? Done? Easy? Can I move on? Now, see, this is the knowledge. These are very important points about dimensional formula, and then we have got something which is known as principle of homogeneity. A very simple thing. Very simple thing. Pay attention. Principle of homogeneity is a very easy thing. Let's suppose if someone is saying to you, what is 5 kilogram plus 10 meter? Your answer is going to be, this makes no sense. It's an absurd problem. It's an absurd question. These two physical quantities are not meant to be added. We cannot add them. Got it? See, till now you know how to add different physical quantities. You know, if we have got scalar quantities, you can simply add, for example, 2 kilogram plus 3 kilogram is 5 kilogram. If you have got vector quantities, now you might be knowing it, that 2 meter per second plus 3 meter per second can be added using vector algebra. But if someone is going to say what is 5 kilogram plus 10 meter, then we don't need to give answer, because this is an absurd question. This is an absurd question. It doesn't make any sense. So this is what principle of homogeneity means, and we are going to again use it extensively in units and dimension. Principle of homogeneity basically means that if you have got a situation like A equals to BC plus D plus EFG, something like this, right? You have got a situation like this. So basically we are going to say that whatever is the dimensional formula of A, same is going to be the dimensional formula of B multiplied by C. Same is going to be the dimensional formula of D. Same is going to be the dimensional formula of E multiplied by F multiplied by G. Right now I don't care about what is the dimensional formula of only B or what is the dimensional formula of only G. I know one thing, that if let's suppose this is Newton, then this will be Newton, this will be Newton, and this entire thing will be Newton, because only similar physical quantities can be added. Got it? You can either write 5 kilogram plus 10 kilogram, or you can write down 5 meter plus 10 meter. So if someone is talking like this, that means it's an absurd question at the first place, right? So we are not going to answer this. So if someone is saying that A is equals to BC plus D plus EFG, then whatever EFG are individually, we don't care, but combining them, the product of these three things will give me whatever A is, whatever physical quantity A is. Got it? And the perfect example is, we have got many examples, like for example as V is equals to U plus AT. So V is velocity. V is velocity. Let's forget whether it is final or initial. In units and dimension, we are not going to talk about the specific things of the formula. We are dealing with only dimensions. U is initial velocity, forget about it. For us it is velocity. So this is also velocity. Now what I am trying to say is, I really don't care what A and T are, but definitely when you are going to combine them, this will also become velocity. It has to become velocity, right? And now you can also check, when you are going to talk about acceleration, acceleration is actually meter per second square. When you are going to talk about time, it is second. Second and second cancel, meter per second. A very easy example, and so many examples, doston, so many examples, right? Like for example, just now we were talking about F equals to 6 pi eta RV. Now I really don't care what eta is, R is, V is. I know this is Newton. This is Newton. So I now know that when I'm going to multiply the unit of eta with radius and with velocity, I will get my answer as Newton. I must get my answer as Newton. Or S equals to ut plus half at square. This is meters. I know it is displacement, but I am looking at as meter. So U and T will also be meter. It is, and half doesn't have any unit. It is a constant, positive constant. AT square will also be meter, nothing else. So this is your principle of homogeneity. So simple, right? Very, very simple. Got it? Pretty easy. Now let's come back to this problem which we just saw. That's what I was saying, that F is, let's suppose F is force, so this entire thing will be force. My dear friends, in this entire thing, cos is dimensionless. It means that A is also force. A is also force. दोस्तों, sine is a dimensionless. That means C is also a force. C is also a force. Got it? Done? Bx is also dimensionless, and this entire thing is also dimensionless. So the remaining quantity is only A. So that means A has to be a force. Again, C has to be a force. Done? Moving on. Let me give you a nice problem out of this. Be quick. Let me know this one. Using the principle of homogeneity, determine the dimensional formula of quantity A. See, please note, either they are going to specify what things are, like for example as P is pressure, X is distance, and T is time. We need to find out A. We don't have to worry about anything. See, chalo, first of all, I'll open the poll for this. Again, 90 seconds for you. Think about it. Then we'll discuss. Okay, come on, be quick. Come on. Very good. Very, very, very good. My dear friends, we have got something like pressure is equals to A minus T square whole divided by B multiplied by X. Fine. Great. Thank you. Now, somebody might think, sir, we'll have to also find out B. If you're going to ask me, I'll simply look at only one thing. I'll look at this particular point, that we are writing something like A minus T square. See, if we have got multiplication of two things, or if you have got division of two things, we can't apply principle of homogeneity. Please understand one thing. Doston, listen to me very carefully. I know you have got your answer. Very, very good. Let's suppose someone is saying force divided by capital A. I cannot really say anything about capital A. Capital A is, by the way, not area. But what I am trying to say, I cannot say anything about A. Cannot say anything about dimensional formula of A. But let's suppose someone says that force plus A, then it is absolutely certain that A is also a force. Got it? Got it, my dear friends? So we really don't care what B is or what A minus, by the way, A minus T square upon Bx is of course pressure. But we don't have to talk about all of those things. If someone is writing something like this, that means A will have the dimension of T square. A will have the dimensions of T square. Got it? That's all. Answer 3 is absolutely correct. Why? Almost all of you are saying C, so why poll is not taking the answer here? Is there any problem in poll? Got it now? Let me give you one more example from this. Let's slightly increase the level of the question. Something like this. Come on. Be quick. In a book, the answer of a particular question is expressed as B equals to MA upon K times root of 1 plus 2KL divided by MA. Here M represents mass, A represents accelerations, L represents length, then the dimension of B should be. 90 seconds. Let's start. Come on. Chalo, let's see if poll is working in this problem or not. If it will not work, I'll see. Come on. B is MA divided by K times under root of 1 plus 2KL divided by MA. This is the given expression. My dear friends, this is inside the under root and I can see a 1 written over here and I am taking this as dimensionless. So this entire thing will become dimensionless, which means that KL will have the dimensions of MA, so that both of these dimensions can get cancelled out and it will again become dimensionless, right? So Ka will have the dimensions of Ma. This means that K will have the dimensions of M is mass, L is acceleration, and I have got a L over here. I am cross multiplying L. We can do this. L and L gets cancels out. This is the dimensional formula of K. By the way, we want to find out the dimensional formula of B. We want to find out the dimensional formula of B. This entire thing is a dimension. This entire thing is dimensionless. Clear? So that means B will have the same dimensions of MA divided by K. B will have the same dimensions of MA divided by K. M is mass, A is acceleration, and now we know what K is. K is mass times T raised to the power minus 2. Cancel, mass cancel, answer comes out to be L to the power 1. L to the power 1 means third is the correct option. Great. Poll is working. Poll is working, but still I am getting do we have Kaveri in the chat, right? Okay. So poll is working, but I'm getting less answers in the poll. I don't know. I mean, hopefully you guys have this pi lens. Maybe it's not working because you don't have pi lens, huh? So make sure you do have pi lens, probably because of this. Clear, dosto, till here? Let's talk about one or two more problems related with dimensional, with principle of homogeneity. It is one of the important topic from this particular chapter. This is the next question. The equation dv by dt is equals to at minus bv is describing the rate of change of velocity. This is rate of change of velocity of a body falling from rest in a resisting medium. The dimensions of a and b are, come on, starting the poll, 90 seconds, let's start. You need to give the answer after I am going to start the poll and under the time. Got it? Under 90 seconds. Be quick. Can we do it as L equals to MA divided by K? I guess if you're getting the right answer, then yes. Be quick. The equation dv by dt is equals to this. And dv by dt is rate of change of velocity. Rate of change of velocity is acceleration. Dimensions of A and B are dv by dt, right? Is equals to at minus bv. So we all know this is nothing but acceleration. Acceleration is L1 t minus 2. So this whole thing will be also, dimension of A will be L1 t minus 2 divided by t, which is L1 t minus 3. Clear? AT will also have the same dimension. So I am simply cross multiplying that t into the denominator. We can do this simple thing, right? Sir, my account is blocked on PW app, so I am unable to use Pylens. Why, buddy? Why it got blocked? What you have done? BV, same thing will happen with BV. BV is equals to, I mean, the dimension of this will be same as that of acceleration, right? Because this is acceleration. So this whole thing is acceleration. This whole thing is acceleration. So B will have the dimensions of acceleration divided by V, and I'm believing V is nothing but velocity, right? So that is L1 t minus 1. So this gets cancels out and we are getting t minus 1 as the final answer. I mean, for B. So t minus 1 and L. So first of all, L1 t minus 3. L1 t minus 3 is only in 2. And then, so second is the correct option. Got it? Kindly see, these many questions are more than sufficient. We have covered almost all types of problems. Obviously, you can solve some more problems by yourself. Very good. Again, only 2 students. I mean, Pylens is only showing 2 students. I don't know why. Okay. Come on, quickly write down in the chat box if everything's clear till this point. Last problem from this side, then I can give you 1 or 2 more questions from mains also. Come on, let's do this. Be quick. The velocity of a particle depends upon the time t according to the equation this, right? You have to find the answer. Starting the timer, 90 seconds. Velocity is equals to under root AB plus BT plus C upon D plus T. C upon D plus T. I am not on Pylens. Download Pylens. Be quick. Please see. Again, this is velocity. So this entire thing will be velocity, which means that under root of AB will be velocity. But let's come back to this after some time, because we can easily see what D is. I'm going to instantly see at this point, and I'm going to say that because you are adding D with time, then the dimension of D is definitely that of time. Got it? So D is nothing but time. So they were talking about A, B, C, D. That's why we have got time in at least all three, right? Then C upon time is actually, this is velocity. This is velocity. Here, so C will be velocity. Velocity is basically distance divided by time multiplied by time. So this will be length. So this is going to be, C will be a length. That is distance, right? So the C last second is distance, and then B times T, this is velocity, and velocity divided by time is acceleration. Velocity divided by time, that means B is acceleration. So second one is acceleration. So second one is acceleration, then you have got distance, then you have got time, and then let's talk about A. So A times B, B is, by the way, velocity divided by time and root of it, and this is again velocity. So I'll simply write A times velocity is equals to velocity square multiplied by time. So that is again length. So distance, acceleration, distance, time. So B is the correct option. Clear? Any doubt? Kindly write down in the chat box. B is absolutely correct. Again, most of you have said C. Kindly note it down and let me know if you have any doubt. Clear? It's a nice problem. Nice question. Any more doubt? Here, one problem from, see, this is from mains 2023. They are saying electric field in a certain region is given by this, A upon x square, I cap plus B upon y cube. You have to find out the SI unit of A and B. Done? Let me start the poll for this as well. 60 seconds. Let's start. Use simple principle of homogeneity only. Very good. Simply use principle of homogeneity. A upon x square will have the same dimensions that of electric field, right? So A will have the same dimensions of electric field multiplied by x square. Electric field is nothing but, I mean, let's talk, because they are talking about in units, let's write down electric field is Newton per coulomb and this is meter square. So A will have unit of Newton per coulomb. meter square. So Newton per coulomb meter square, I think only one option is matching, that is B. But let's also talk about the second, B upon Y cube. B upon Y cube will have the same dimensions that of electric field, right? And unit of electric field is again Newton per coulomb. So B will have the unit of Newton per coulomb meter cube. That's what option B is. B is going to be the correct option. All right, chalo. At least now it's saying some more answers. Great. We are going to start motion in 1D, but that's going to be our next chapter. Next chapter, sorry. In next chapter, we will cover vectors. We have already completed differentiation, integration. I believe differentiation, trigonometry, right? In our previous YT lecture, YouTube lecture. So now we are going to, in basic maths, next week we are going to complete vectors. We are going to solve questions from integration, differentiation, and then we are going to take one dimensional motion. All right, clear? Fine. So now, my dear friends, we have talked about principle of homogeneity. We have solved 1, 2, 3, 4, 5, 6, at least 6 problems, right? Now the next type of questions are, which are again very important, are related with relationship between or relations between physical quantities. Relation between physical quantities. Right? Something like this. Done? Pay attention. Let's suppose we are writing one formula. We are writing one formula, something like this, that time period is equals to 2 pi under root L by G. 2 pi under root L by G. This is a formula that I hope we all know, right? Where this is time, this is time, this is acceleration due to gravity, and this is length of the string. Done? So using relation between physical quantities, we can actually try to derive a formula, or we can try to find out the relation between physical quantities. We won't be able to derive the exact formula, that the reason I'm going to just now tell you. But let's suppose someone is saying that time depends upon length, time of what? Time period of a simple pendulum. Got it? Time period of a simple pendulum depends upon length and acceleration due to gravity. But they have not told us how it depends. So what we can actually do is, we can say that, let's suppose time actually depends directly on length raised to the power x, gravity raised to the power y. We can say something like this. Got it? We can say something like this. We don't know how it depends. Our target is this. Our motive is to derive that formula. We don't know the powers on L and G. So let's suppose that power on length is x, power on G is y, right? And let's remove this proportionality sign and let's write down a proportionality constant, right? And in this case, it comes out to be 2 pi. and let's say this is L raised to the power x and G raised to the power y. After this step, my dear friends, what we are going to say is we are going to again use similar similar concept to that of principle of homogeneity. We are going to say, see, if this is time, then the dimension of time can be written as there is no mass, there is no length, t raised to the power 1. Over here, my dear friends, you can do the same thing. You can write down, instead of length, we can simply write down this is nothing but L raised to the power 1, that is L raised to the power x. Dosto, this is acceleration. Kindly note, this G is an acceleration, right? Acceleration basically means there is no mass, but certainly there is length, and there is t raised to the power minus 2 and whole raised to the power y. Got it? So in the next step, we'll get something like this. T raised to the power 1. I'm not rewriting M0, L0. This is K. This is L raised to the power x, and I also have L raised to the power 1 times y. So I'll write down plus y. And then T raised to the power minus 2y. This is your final step. After this, now you can compare it. Compare what? You can compare length with length, time with time, and any physical quantity with the same physical quantity on the other side. We all can easily see that here you have got t raised to the power 1, here you have got t raised to the power minus 2y. So that means minus 2y is equals to 1, which means that y is equals to minus 1 by 2. Y comes out to be minus 1 by 2. That means on gravity, power should be minus 1 by 2. Got it? On gravity, power should be minus 1 by 2. Then also x plus y. Now you are going to say, sir, here you have got length, but on left hand side we don't have any length, which means that x plus y is equals to 0, which means that x is equals to y, and now we know y is minus 1 by 2, which makes my bad, this is minus y, which means x is actually equals to plus 1 by 2. So we have got a situation something like this, my dear friends. Time is equals to some constant which we don't know, some constant k, L raised to the power 1 by 2, G raised to the power minus 1 by 2. What do we mean by this? We mean to say k, L raised to the power 1 by 2, G raised to the power 1 by 2, or you can say this is nothing but k under root L by G. Hopefully you guys are understanding how we can use the relations between physical quantities to come close to our desired formula. Now you might say, what about that constant? We cannot find out the value of constant through this method, and this is one of the limitations of this method. We won't be able to find out the value of proportionality constant, right? I mean, all of these proportionality constants are usually found out by physical experiments, by taking readings. Got it? But our objective is not that. Our objective is simply to find out the relation between time, length and gravity. If someone is going to say that time period depends upon length and gravity, find out how it depends. So we are only trying to find out the dependency, in which manner it depends. Got it? Done? So remember it, this was just one example. We can use similar things to solve many other questions. Now let's move to one of the PYQ from JEE Mains. This is one of the PYQ from JEE Mains. Kindly read it. If the velocity of light c, which is represented by c, and then you have got universal gravitational constant g, and then you have got Planck's constant h, are chosen as fundamental quantities. These are chosen as, let's suppose, fundamental quantities. Then the dimensions of mass in the new system will be. Kindly don't get confused with conversion of units. I'm going to explain that as well. Don't get confused with conversion of units. Here they are only saying that what we want is, we want to write down the dimensions of mass. That means mass actually depends upon velocity of light, that is c. Now depends upon, right? We really don't know whether it depends directly on it. So we are going to write c raised to the power x, let's suppose. And it depends upon g, so let's say g raised to the power y. And it depends upon h, so h raised to the power y. I'm sorry, because they have talked about h, c and g. Let me use the same order. Let me use the same order. That is h raised to the power x, and then c raised to the power y, and then g raised to the power z. Got it? This is what they are saying. So we need to find out the value of x, y and z. New system basically means, let me tell you what new system is. Hold on. Let me tell you what new system is. Fine. See, whenever you are going to ask me any doubt in the chat box, I'll definitely reply. New system basically means, if you are going to ask me, sir, how to represent time, or if let's suppose I ask you how to represent time, so you are going to say, sir, it is quite simple. Time will be represented by something like this. There is no mass, m0, l0, t1. This is how we are going to represent time. Now I am saying, if you are representing time like this, you are actually choosing those 7 fundamental quantities. You are going to say, sir, there are only 7 fundamental quantities. So I am going to say, let's say we have got an imaginary system, and in that imaginary system I have changed fundamental quantities, and I have changed the fundamental quantities to length, which is again one of the fundamental quantity, and gravity. Now tell me how you are going to write down time in terms of length and gravity. So you are going to say, sir, fine, it will be written as some constant k, L divided by g whole raised to the power 1 by 2. This is how you are going to write down, which means that you are going to write it down like time depends upon length raised to the power 1 by 2, g raised to the power minus 1 by 2. So I am representing a physical quantity in terms of new system, new unit, not unit, but new system of quantities. So these are our imagined hypothetical fundamental quantities. Got it? Done? Doubt clear? So in this case, we have got situation like this. Kindly read. They are saying velocity of light, gravitational constant are chosen as fundamental quantities, which means that mass is directly proportional to h to the power x, c to the power y, g to the power z. And that is why I was saying ki kindly remember the dimensional formula of these things. Because everyone remembers this is going to be simply L1 t minus 1. Remember for g and remember for h as well. Done? Doubt clear? So let's quickly solve this this question. Here you have got everything written, dimensional formula of c, g and h. So we want it for mass, right? So mass m1 is equals to some constant k. Then I believe first we have got Planck's constant, hc. So Planck's constant, that means L t minus 1, no sorry, Planck's constant is m1 L2 t minus 1 whole raised to the power x, and then you have got c and then g. So c is Lt minus 1, so this is y, and then you have got g, that is m minus 1 L3, and then t minus 2, and this is z. This is our first step. Next step is going to be again rewriting this whole thing, m1, and this is k, this is m x. We don't have any mass, we have got mass minus 1, that means this will become minus z. Role of mass is now over. Done? L raised to the power 2x plus y plus 3z. And then for time, you have got minus x minus 2z. Minus x, sorry, minus y also. Minus y minus 2z. Kindly note this point. This is an important step, right? Again, see mx, then minus z, L 2x, then minus, then plus y, this is plus y, and then plus 3z. Then for time, minus x, minus y, minus 2z. Clear? Done. And after this, let's compare them. So when we are to compare it, we have got mass, so that means x minus z is equals to 1. You have got m raised to the power x minus z, you have got m raised to the power 1. We don't have any length on the left hand side, therefore 2x plus y plus 3z is equals to 0. We don't have any t either on the left hand side, so minus x minus y minus 2z is equals to 0. Here you can also, if you want, you can also actually remove this negative sign if you want, right? If you want. If you don't want, fine. Now, my dear friends, according to me, we can see you have got an xz over here. So simply add these two equations. Simply add these two equations. Because if you are going to add, this y and y will get cancelled out. And you will get 2x minus x, that is x, 3z minus 2z, that is plus z, is equals to 0. Which means that from here you can write down x is equals to minus z. So x is equals to minus z, substitute this value in this equation. So this means that instead of x I can write down minus z. So minus z is equals to 1, which means that z is equals to minus 1 by 2. Z is equals to minus 1 by 2, one answer. Then x is equals to minus z, which means that x will be equals to plus 1 by 2, second answer. And then the third answer is going to be using any of these two equations, right? So minus x, that means minus 1 by 2, and then minus y, that is y we want to find out. So minus y and minus 2z. So minus 2z is equals to 0. So this becomes plus, this becomes 1. So y becomes 1 by 2. This is going to be your answer. Come on, be quick. Let me know if you have any doubt. Done? Clear? Be quick. So x is plus 1 by 2, then 1 by 2, 1 by 2 and minus 1 by 2. I think D is the correct answer. 1 by 2, 1 by 2 and minus 1 by 2. Here 1 by 2, 1 by 2 and minus 1 by 2 is the answer. Please note it down, and if you have any doubt, do let me know. This is again, see, I have given you two examples till now. This was your first example and this is your second example, which came in JEE Mains 2023. If you are going to see NEET 2025 paper, a similar question has been asked, right? Let me know if you have any other doubt. Poll, I don't think so. I've given poll for this problem, but fine. Here, great, very, very good. Now, few students were asking about this new system question, right? So, see, don't get confused. When someone is saying new system, now you know what they want us to do, and this is going to be the difficulty level. Sometimes they can also do one thing. Let me explain that thing also. Kindly note how many unknowns we have got over here, right? So this is something that I am telling you additional to this problem. We have completed it, but now this is also very important. You have got three unknowns, x, y and z, right? So you have got three unknowns. Three unknowns basically means that to solve all of them, you must know at least three equations. Got it? You must know three equations. Sometimes it can happen that unknown might be more and number of equations will be less. So what you can do is you can always solve these types of questions by eliminating the wrong options. If you are going to eliminate the wrong options and you are now certain that D is the correct option, then you do not have to find the other variables. You don't have to find out all the unknowns. It is a very important point because you can also see that it is slightly time taking. In NEET 2025, similar thing happened. If I am not wrong and if I am recollecting from my memory correctly, then there were, I think, 5 unknowns and we were able to only form 3 equations. So using those 3 equations, if you are able to find out 2 answers, 3 answers, then that's fine. You can also use trial and error. You can also use trial and error to find out the values. Got it? So do not think that you have to find all the unknowns to mark the correct option. Now moving on to next topic. Next topic is, my dear friends, conversion of units. Again, a very simple topic that you have been doing since. Conversion of units that you have been doing from your junior classes. So it's not a big thing, right? I mean, it's pretty easy. Like for example, as everyone knows, 1 kilogram is equals to 1000 gram. What we are trying to do over here is, we are simply saying this is, this is the numerical value, let's say n, and this is the units, let's say u1. This is our new numerical value n2, and this is our another unit, that is u2. But our point is that the combination of these two will remain constant for a given physical quantity. For a given physical quantity, it will remain constant. Let me tell you this point again. Let's suppose we want to find out length of this pen. Length of this pen is an information. Length of this pen is an information. We are going to communicate, we are going to deliver this information using a magnitude, a numeral value and a unit. So the information must not change. Way of representing it might change. So either you can say 1 meter, you can say it as 1 meter, or you can say it as 100 centimeter. Information is same, way of communicating is slightly different, numerical value is different. So product of numerical numeral value and unit will remain constant. Got it? So using this concept, you can say a simple thing, that n is inversely proportional to u. The bigger the unit is, smaller the number will be. How easy it is? Kilogram is a bigger unit, na? Kilogram is bigger or gram is bigger? Obviously kilogram is bigger, so number is small. You are going to find out various such questions in which they are going to say that we are changing the unit of density from gram per centimeter cube to a new unit, where instead of gram we are going to select 10 gram as the unit. Instead of centimeter we are going to select 10 centimeter as the unit. Got it? You're going to see lots of problems like this. So you don't have to do anything, you have to remember this small thing. Let me give you one example. We can take this also as an example, but let's start with Newton. You all know what 1 Newton is. 1 Newton is nothing but 1 kilogram meter per second square. Let's change its unit. Let's change this unit to CGS system. CGS unit system, right? So what we are saying is, this is 1 kilogram meter per second square is equals to N2, because this is basically, we are writing this is N1 multiplied by this system. Clear? Multiplied by this system. So now let's write it down as N2 multiplied by gram, centimeter and second square. So we don't have any problem with this thing. Clear? We want to find out N2. So if you want to find out N2, you are going to write something like this. N2 equals to 1 kilogram divided by gram, and then you have got over here as meter divided by centimeter, and you can find out the value of N2. So you have been doing this. I mean, before this we were quickly finding out, like for example, as 1 kilogram will be 10 to the power 3 gram, 1 meter will be 10 to the power 2 centimeter. That's it. So this comes out to be 10 to the power 5 gram centimeter per second square, or 10 to the power 5 dyne. So similar kind of thing. That's all, right? So now after this step, what you can do is you can write down 1 kilogram can be written as 1000 gram. So gram divided by gram, gram cancel. Meter can be written as 100 centimeter, centimeter cancel. And per second, we don't have any problem with second square, huh? It's already being cancelled. So this N2 comes out to be 10 to the power 5. So that means in CGS system, we can write the N2 is 10 to the power 5 and CGS unit is gram centimeter per second square, or this thing is also known as dyne. So what I'm trying to say is we have been doing this from our, I don't know, I mean from 6th, 7th, 8th class maybe, right? So this is old stuff. Now the only thing is, when let's suppose they are going to talk about some new system, that's where you are going to face trouble. Let's suppose instead of instead of saying that gram is one of the unit, they are saying 10 gram is one of the unit. So what problem? We don't have any problem. We are going to again do the same thing. Let's suppose they are saying what is the value of 40 gram per centimeter cube into the new unit. So you are going to say 40, that is N1 U1 is equals to N2 U2. Now instead of U2 you have got 10 gram 10 centimeter. Same logic, same thing, no difference, right? And instead of N1 you have got 40. So using this small formula, it's not even a formula, it's simply a statement, N1 U1 equals to N2 U2. You can find all questions of conversion of units. Clear? Quickly write down in the chat box if you have any doubt. Let me know. Be quick. Sorted? All right, great. So see, till now in around 1 hour 15 minutes, we are able to complete all of these things. That's why, see, I was not writing all of these things on the board, because I mean, we all know units and dimension. The first part of units and dimension is slightly theoretical, slightly boring also. So that's why I've given you these notes. This is very important. I've explained as much as it was possible. These things are also completed, and after this we have talked about principle of homogeneity. We have solved sufficient questions on this particular thing, and then we have discussed relation between physical quantities. We have talked about 2 examples. I mean, now you can solve more examples by yourself, right? And then conversion of units as well. Now let's talk about errors in measurement. Right now we are not starting instruments. Right now we are talking about errors in measurement, and last topic is going to be instrument, right? And at last I'm going to also tell you the flow of the chapter, right? In hindsight, what we have done. Clear? When we are going to about to start instrument, I'll explain what we have completed till then. Let's talk about errors in measurement, and we can also discuss the flow till now as well. Like for example, as measurement, we were talking about measurement of this pen. Clear? We were talking about where you can get notes. You can get notes from WhatsApp channel. WhatsApp channel of PW NEET English. It will be notified to you through description box after the class is over. Now pay attention dosto. Let's suppose I want to find out the length of this pen. Clear? Length of this pen is an information, we are going to deliver it, and it is we are going to use physical quantity to deliver this information. Physical quantity is going to be the length. So first of all, we have started our chapter with understanding why we use physical quantities, right? And if we have to deliver information, then the information will be delivered using a numerical value plus a unit assigned to it, a system assigned to it. Got it? So we have talked about something about measurements, numerical value and unit. Now when you are going to measure it, we are going to measure it using some instrument. That's what we are going to talk about in the last part of this chapter. Got it? So how to measure is the last topic. But after measuring it, when you are going to give answer, then that answer, that reading will be called as the measured reading. Got it? It will be called as a measured reading. Now, if let's suppose the measured reading is not exactly equals to the actual reading. Let's suppose we are measuring the reading of this pen and we measure it 9 centimeter. And when we are going to see the box of this pen, I mean this pen will come in a box, right, from the manufacturer of this pen. The manufacturer exactly knows the length of this pen, because I mean he or she is producing it and manufacturing it, so they actually know the exact length. So let's suppose we measured it and we came to know that the length of this pen is around 9.5 centimeter. And when we checked the length with the box of this pen, we came to know that the actual length is 10 centimeter. So there is something that is called as measure length, and then there is something that is called as actual measurement. The difference between these two will be called as error. The difference between these two will be called as error. I mean, sometimes you might say actual minus measured or measured minus actual, right? This will be called as error in the measurement. This thing will be called as error in the measurement. Very simple. Now see, we are going to now talk about why do we have errors, and for that let's understand types of errors. So the first error is random error. First type of error is random error. As the name suggests, these errors are going to be random. Sometimes when we are going to talk about random errors, sometimes the measured value will be greater than the actual value, or sometimes the measured value will be less than the actual value. And if let's suppose you are taking tens of readings, if let's suppose I have given, if I have given 10 students and I have said ki please measure the length of this pen, so someone is marking it as 9.6, someone is marking it as 10.3, someone is marking it as 8.6, someone is marking it as 11.2. So errors can be random, right? So these are going to be random errors. Then systematic, we have got second types of errors are known as systematic errors. In this you have got instrumental errors. These errors happens because of error in instrument. Got it? Then you have got procedural error, and then we have got personal error. Although again types of error is not super important for NEET exam, but they can give you one or two statement based question. We are going to read the definitions of each one of them, and these are something like this. So systematic or controlled errors, errors that tend to be in one direction. That means every time you are going to take up a reading, measurement will be either greater than the actual value or will be less than the actual value. This is called as error in one direction. Got it? So instrumental error means due to the imperfect design or calibration of the measuring instrument. Zero error is one of the instrumental error. We are going to discuss zero error when we will be talking about vernier caliper or screw gauge. And then you have got experimental technique. let's suppose due to flawed experimental procedural inaccuracies are generated. That means if let's suppose you have got some experimental flaw, you are experimenting it but you have not arranged the procedures, you have not arranged the equipments correctly, so we can also have experimental technique error, or then you can have personal. It's not that much important, but read it. If you are going to read it once, you can remember it. Due to an individual's bias, lack of proper setting of the apparatus, or individual carelessness in taking observations, this is known as personal error. This will also come in systematic or controllable errors. And then you have got random. As I have said once, errors which occur due to unknown or unpredictable changes in the experiment, these are known as random errors. Got it? Now let's talk about something which we are going to use in numericals. All right, we are going to now use the concept of absolute error in numericals. So pay attention. What do we mean by absolute error? Again, I'm going to give you a similar example. This is, let's suppose this is our pen. We want to measure length of this pen, correct? And as we are measuring it, and let's suppose we also don't know the actual length, right? Let's suppose actual length is not known. Actual length is not known. So what we can do is we can perform the experiment many times. We can perform the experiment, and as we are going to perform it, we are going to call it as x1. That means reading observed during experiment 1, then x2, x3 and so on. x1, x2, x3 and so on, xn. Using this concept, we are going to find out the arithmetic mean of all of these things. So arithmetic mean would mean x bar, that will be x1 plus x2 plus xn whole divided by n, whole divided by n. And then this value can be considered as the actual value. See, this is a really interesting point, and sometimes students get confused in this. So pay attention. I have told you that we don't know the actual value of the length of a measurement. Length is just an example. Let's suppose we don't know the actual measurement. We have started this particular topic by saying that error is basically measured value minus actual value, right? We have said this, measured value minus actual value. Now we are saying, let's suppose we don't know the actual value. If you are not going to know the actual value, then how come you find out error in it? So we have got one very interesting method to find out the actual value. That method is by finding out the arithmetic mean of different measurement. But how will it work? Let me give you one example. By the way, I have also seen this thing on I think on Discovery Channel or on YouTube somewhere, but I do remember it correctly. They have done a social experiment. You know what social experiment is? In a fair, in Hindi we say Mela. I don't know about other languages, but in a fair, let's suppose we have got an elephant, right? Don't expect me to draw an elephant. Let's suppose we have got an elephant in a fair, and we are asking to the people who have came to the fair, we are asking them what is going to be the weight of this elephant. I mean, obviously, if you are not a wildlife enthusiast, then you might not know the weight of elephant. And when you ask people, you ask layman people, you ask ordinary people who are not directly connected or who do not have sufficient knowledge about those things, so they can come up with very random answers, right? For example, as let's suppose a person uh, who is not really interested in motorbikes, then they might not really know what are the weights of different motorbikes, right? So what is the weight of Pulsar, what is the weight of R15, or what is the weight of a particular car? They might not know and they might guess it very badly. So what they have done is they knew this thing. The people who were conducting the experiment knew this thing, and they said ki we want people to guess the weight of the elephant. So what happened was, there was the actual weight, and what people has done is, many people actually guessed the weight of an elephant to be far more than the actual value, and then there were people who guessed the weight of an elephant far less than the actual value, and there were few people who guessed the weight of the elephant near to the actual value. So what I am trying to say is, by doing this method of guessing and taking the average of all of these value, you can actually cancel out the inaccuracy because of inexperience. Got it? So we can cancel out that inaccuracy, and the final average value came out to be really close to the actual weight of the elephant. This is a social experiment, but this is only possible when you have got a sufficient large sample size. Obviously, it will not work if you have got 5 friends and all of those 5 friends are guessing the weight of an elephant. That will not work. But if you have got large number of people and they start to guess things, the average value of all of those measurement comes exactly close. Got it? Not exactly close, but too close to the measurement. So this is exactly what we are trying to do over here. Now we are not actually guessing. We have got a measuring instrument, we are measuring it, and then we are taking the average. So when you are going to take the average of these measured values, then you can say ki ha, this is going to be exactly or nearly close to the actual answer. Got it? You guys are buying what I've just said. This is an example why we are saying that we don't know the actual value, but we can assume the actual value to be the mean value of n experiments. Done? So now this will be taken as the actual value. So the absolute error will be written as delta A1. So this is called as absolute error in measurement 1. This will be called as absolute error in experiment 1, and you can now write it as x1 minus mean value. Done? No, we will get it. Somebody has written, but sir, we won't get the real actual value known in average. No, we will get it. That's what I've said till now. Done? Clear? Then you have got delta A2, that will be written as x2 minus x bar. Then you have got delta A3, this will be written as x3 minus x bar, and then so on. And you have got delta an, and you can write it down as xn minus x bar. And then we can take the average of all of these errors. We can take the average of all of these errors as well. That will be called as mean absolute error. We don't have I mean, I have not written mean absolute error in this, but this is just about, so these are absolute error. Absolute error in measurement 1, 2, 3, 4. If let's suppose someone tells you the actual value, so you can assume this says exactly the actual value, or the mean value can be also considered as an actual value. Clear? Done? Let me give you one example. By the way, notes are written over here. So you don't have to worry about, these are your notes, right? This is mean absolute error. So the only point is, take the magnitudes only. So these are the magnitudes only. These mods are because modulus, because we want to take only magnitude only, right? Some of them are going to be positive, some of them are going to be negative. So when we are going to talk about mean absolute error, we are going to only talk about the magnitude of all of these things. Done? Clear? Other than this, my dear friends, then you have got next two types of errors. First one is relative error. In relative error, we say mean absolute error. That means delta A bar divided by mean value. If you are going to multiply it by 100, you will get percentage error. Done? Don't worry, I am going to explain all of these things using one example. Let's suppose this is the example. Pay attention. The length of the two rods. Achha, this is sum and difference here. Just a second. We have not talked about sum and difference till now. Let me see if we have got some examples over here or not. No, we don't have examples. Okay, fine. I'll come back to the example after we discuss errors in sum and measurement. Okay, then we'll come back here because here they are talking about sum and difference. We have not covered that. We'll come back to this. See, hopefully everything is clear till percentage error. Done. Now please see error in sum and difference. When we are going to talk about errors in sum and difference, pay attention. Let's suppose you have got two quantities and you are adding A plus B, and the maximum absolute error in X, maximum absolute error in A is delta A, maximum absolute error in B is delta B. So maximum error in X is going to be delta A plus delta B. Got it? So this is for addition. Even if we are going to talk about subtraction, maximum error will be only written with a positive sign. That means maximum error in A is delta A, maximum error in B is delta B. So delta X will be delta A plus delta B. Let me explain this to you. Now we can talk about this as an example. They are saying length of two rods are, so A is 25.2 plus minus 0.1 centimeter, right? And B is 16.8 plus minus 0.1 centimeter. So what we are trying to say is that even when you are going to write A plus B, add them, this will become 10, 1, right? So 2 and 3. So this will become actually 42. Clear? This will become 42. And errors are always going to be added, but we are going to write it with a plus minus sign. So 0.1 and 0.1 will become 0.2 centimeter. So this thing is actually known as delta A plus delta B. So we always add errors even when they are going to talk about A minus B. So you are going to write down 25.2 minus 16.8. But still over here you are going to still write down 0.2 centimeter itself, because this is still your absolute mean error in sum or difference. This is what it means, right? And we have got a note also over here. The note is something like this: the errors in the quantities always gets added irrespective of addition or subtraction. Done? Irrespective of its addition and subtraction. Any more doubt? Clear? Be quick. And let's suppose they want to find out the percentage error in the value. So percentage error in the value will be delta A plus delta B. That means error divided by A plus B multiplied by 100. So in this case, your delta A plus delta B is 0.2. So percentage error, if someone talks about percentage error, it would be 0.2 divided by A plus B multiplied by 100. This is going to be percentage error. This delta A plus delta B divided by A plus B. Okay. Alok, you can, buddy, you can ask your doubt, or you can tell me which topic, which specific topic you want me to repeat. I'll repeat it. If you have any doubt in this, I was about to give you example for this one, but I don't have an example. I can make an example for you. I mean, if you have got any doubt in this specific case, I can make one example for you if you want me to do that. Always errors are always added. That's right. We actually, the point is, we always try to find out the maximum possible error. That's what the point is. Unless and until asked otherwise, although they never ask it, we always try to find out maximum possible error. All right. This question, okay, fine, I'll explain this question again. No problem. If you guys are going to ask me, I'll explain the question again. They are saying that we have got two measurements, buddy. We have got, let's suppose this is A, right? Let's say this is A and this is B. Clear? This value plus minus 0.1 centimeter is considered as absolute mean error in A. Absolute mean error in A. Let me explain this point again, because one of the student has asked this. If you remember, doston, we were trying to find out, first we tried to find out the average value of this. Chalo, no problem, I'll give you one example also. Pay attention. Let's suppose we have got measurement of length, something like this. Length of anything, something like this. 9.8, all are in centimeters. 9.8, 10.2, 9.6, 10.4, 9.5, 10.5, something like this. 1, 2, 3, 4, 5, 6. Done. So these are individual measurements. Clear? These are individual measurements. It means that this is A1, A2, A3, A4, A5, A6. Clear? So the first part is to find out the actual value of the measurement. So instead of talking about it as actual, we can also call it as mean. These two means the same thing. So how to do this? So we are going to add all of them. And so on. I mean, let me not write all the values, and divided by the total number of terms, that is 6, I believe. We will be getting some answer. Got it? We will be getting some answer. That value will be called as the actual value. Now the next step is find out the error in the first measurement. So this will be called as absolute error. Absolute error in the first measurement. So absolute error in the first measurement will be 9.8 minus the mean value. Then delta A2 will be 10.2 minus the mean value, and so on. Similarly, delta A6 will be 10.5 minus mean value. And then we are going to find out the average of all of these errors, mean absolute, these absolute error in 1, absolute error in 2, absolute error in 3, and then we are going to call it as mean absolute error. You don't have to write down this M if you are writing a bar over here. Delta means error. Delta A means error in A. Delta A bar means you are averaging every error out. You are adding all the errors and you are again dividing it by the number of terms, right? Now the point is, my dear friends, we only want to take the mod values, else it will get cancelled out. Kindly see, there are two things, my dear friends. If you are going to understand why we are doing a particular thing, if you will question it, you will be able to know it. Let's suppose you don't want to take the mod of this. What will it signify? Hold on, what will it signify? Sum is coming out to be very good, and that's why I have taken these value. This comes out to be 10, I believe, correct? This whole value comes out to be 60 divided by 10. Thank you so much. That means 60 divided by 6, that means 10. Just a second. You can also ask me these things ki why we are taking mod values. The reason is that let's suppose actual value comes out to be 10 and this comes out to be minus 0.2. This comes out to be plus 0.2. So if you are going to, without taking the mod signs, you are going to add them, you might get answer as 0. So you might get that, sir, answer is 0. So looking at this information, we will say that there is no error. But in reality, we have got errors. Some of the values are in negative direction. Some of the errors are in negative direction. Negative direction basically means some of the values are less than the actual value. Some of the values are greater than the actual value. So if you are going to simply assume the sign, errors are going to get subtracted out. And it will appear that there is no error. But in reality, there are errors. Got it? In reality, there are errors. That's why after taking delta A1, delta A2, we are going to take the mod values of this. We are going to take the mod values of this. Fine? Clear? And that is why, so how are you going to finally give the answer? How are you going to finally give the answer? You are going to finally give the answer as any reading will be given as the mean value, actual value, and plus minus this mean absolute error. This mean absolute error. So it will have a range. So range is going to be minimum value can be AM minus delta A bar, and maximum it could be A plus delta A bar. So your answers are going to be in between of these two range. In this range, I should not say these two range, but these two numbers, these two values. And that is why when we were discussing this is a very easy problem. We said ki okay fine, this is error in A, this is the absolute value in A, this is absolute value in B, this is absolute mean error in A. And that is why when we are going to talk about A plus B, we are simply adding them. We are simply adding them. We are not going to minus them or add them because of this operation of sum and difference. Done? Clear? Any more doubt? All right. So moving on, next is, my dear friends, product and division. Product and division. Later on, I am going to also explain you why we actually use, how we have come to this conclusion using the concept of natural log and differentiation. But for now, let's quickly complete this. When you are going to talk about error and division, error in A is delta A, error in B is delta B. So delta X is going to be delta A plus delta B. In this also, delta X is going to be delta A plus delta B. Here we have got one difference. Just a second. Let me explain the method itself. Here we have got one difference. See, actually the derivation is something like this. Let me explain the derivation also to you. All the students who have attended this in my batch, they know what we actually do is we take the natural log both the sides. Natural log X, natural log of A times B. Done. And then what we do is we actually try to differentiate it. But before differentiating it, let's write natural log X. Let's use the property of natural log. So natural log A plus natural log B. And then let's differentiate it. So when you are going to differentiate it with respect to x, let me explain what we are going to do. We are going to actually say that this is natural log x, and let's write dx and dx over here. And let's try to differentiate this natural log x with respect to this x. And similarly, let's write differentiation of natural log a with respect to a, and let's write dA over here. Again, let's do the same thing, differentiation of natural log b with respect to b, and let's write dB over here. So this was our first step, taking natural log, splitting it using the property of natural log. This is the correct method. If you're not understanding it for the first time, fine, no problem, but pay attention. Differentiation of natural log will become 1 upon x. So this will become dx upon x. This will become dA, natural log, differentiation of natural log a will become 1 upon a, and this will become natural dB upon b. Now rewriting this entire thing, we are going to get delta x upon x is equals to delta a upon a plus delta b upon b. So this is how we come to this conclusion. So anytime if you are going to have a new formula, anytime if you are going to have a new expression, kindly remember you need to write down natural log both the sides and then split it and then find out the answer using this method. Over here we are going to use a similar kind of a thing. Pay attention. This will become natural log x, this will become natural log a minus natural log b, right? When we are going to solve it, we are going to get delta x divided by x, delta a divided by a minus delta b divided by b. But we are going to change this sign to positive sign, because again, let me tell you, we always find out the error for maximum possible error. Maximum possible error. Alright, maximum possible error. So this is now, by the way, this is relative error. This is absolute error in x, absolute error divided by x. It means that relative error. Using this, we can also have power rule. This is exactly similar to differentiation. This is exactly similar to differentiation. Pay attention, very easy. You can simply write it as delta x upon x is equals to n times delta a upon a plus m times delta b upon b. Now any student, if any student want to know how we have come to this conclusion, now you know what we are going to do is, we are going to actually write natural log both the sides. So natural log x is equals to natural log of a raised to the power n whole divided by b raised to the power m. First we are going to split using property of natural log. So natural log a raised to the power n minus natural log b raised to the power m. Doston, we are going to again rewrite this negative sign as positive sign, because we want to yes, correct, simple log leke we have to differentiate it. Got it? But there is one different one change. Whenever you are going to come across this negative sign, change it with a positive sign. Why? Because we want to find out maximum possible error. Done. So moving on, this will become natural log x is equals to n times of natural log a minus m times of natural log b. After this step, when you are going to actually differentiate it, this will become delta x upon x, this will become n times of delta a upon a, and changing this negative to positive sign, this will become m times of delta b upon b. Clear? Done. So but now, from now on, you can directly use power rule anywhere you want. And again, this is one of frequently asked questions, like for example as this one. You guys can do it by yourself. We have to find out the relative error. So delta z upon z is actually equals to 2 times of delta a upon a plus 3 times of delta b upon b plus, not minus, plus 4 times of delta C upon C. So that means third is the correct answer. Clear? Any doubt? Please see and let me know. Let's suppose we have got a question like this. In this question, they are saying an experiment is measured, find data is something like this. T is equals to x into y square divided by z cube. X into y square divided by z cube. Clear? And then they are saying if percentage, then percentage error in T. See, the problem is you guys, if you guys are going to only focus on a few questions of similar pattern, then things will become difficult when you are going to see a new question. You need to read these things. Percentage error in T basically means they want us to find out delta T upon T. And now you can remember that, okay, we have got power rule, so we can directly write it delta x upon x plus 2 times of delta y upon y plus 3 times of delta z upon z. That's it. And now if they want us to find out the percentage, then multiplied by 100, and after multiplying by 100, delta x upon x multiplied by 100, they are already saying that it is 1%. So this is 1%, or I'm not using percentage sign. 1 plus 2 times of delta y upon y is 3%. 3 times of delta z upon z is 2%. All of these are in percentage. Answer will become 1 plus 6, 7. 7 plus 6, that is 13%. 13% is going to be the correct answer. Clear? Done? Any doubt? Now let's see. Let's see this one. Pay attention. Here they are saying a wire has a mass of this, radius of this, length of this, the maximum percentage error. Okay? So even if they are not going to talk about maximum percentage error, we are going to find maximum percentage error only. In the measurement of its density, they are talking about a wire. Density of a wire is written by mass divided by volume, which means that mass divided by area multiplied by the length of the wire. So if let's suppose this is density, so the fractional error, we can also call it as fractional error. They are saying maximum percentage error. Percentage error can be also called as fractional error. So delta D upon D will be, first of all, it will be written as delta M upon M plus 2 times of delta R upon R. Pi has no error. Pi, although we are going to consider it as a constant, plus delta L by L. Clear? Multiplied by 100. So you will get your answer in percentage. They want us to find out answer in, obviously, percentage error. They have said it. Clear? So now please see, delta M, error in mass is 0.003. 0.003. Don't worry about the unit. This delta M is in gram, this is in gram. It will get cancelled out. Divided by mass is 0.3. Multiplied by 100. Let's multiply this 100 with each term. 2 times of delta R. Delta R is 0.005. divided by R is 0.5, let's not worry about the unit, multiplied by 100 plus delta L is 0.06 divided by 6 multiplied by 100. दोस्तों, first of all, I can cancel out 1 point with this and then 2 points with this 100. Similar thing. Clear? 5 and 5 gets cancels out, 3 and 3 gets cancels out, both points gets cancelled out by this. This is also 1. So till now I am getting 1 plus, I believe this is 2 plus that is 1. So answer is 4%. Answer is 4%. Clear? Done? Let me know. If you have any doubt, let me know. Option B. Option D, na? Huh. Here. We can discuss some more problems, like for example as T equals to 2 pi under root L by G. Here. So delta T upon T will be equals to 1 upon 2 delta L upon L plus 1 upon 2 delta G upon G. This is one of the formula. Let's suppose we want to rewrite this formula and we want to rewrite in terms of gravity. So this will become T square 4 pi square L by G. Or if you want to make G as subject, it will become 4 pi square L divided by T square. So that means delta G upon G equals to delta L upon L plus 2 times of delta T upon T. Remember these few things. You can also get questions from here. Here. Hopefully everything is clear till now. Now let's start vernier caliper. Instruments. Now as we know how to deal with errors, now let's complete our last topic for today's class, that is, these questions are easy. So I mean, if mostly you're going to get these questions only. If let's suppose you get a difficult problem from this part, then kindly use this thing, natural log, right? If I mean, there are only two possibilities. Either they can ask you a question like this from units and dimension, and buddy, these questions are from mains, hai na? And it's not like that they are going to ask super difficult question from units and dimension. Units and dimension is an easy chapter. So they can do two things. Either they can ask you a direct question like this, or they can give you a slightly different problem in which you can use natural log. So I have explained that as well, right? So we are not dependent only on formula. I have told you how you can actually use natural log. You're going to only use two things, either property of multiplication or property of division. In division, again, you're going to change the sign from negative to positive to find maximum possible error. Got it? Done. Let's now complete vernier caliper. Okay, done. So now please see. First of all, let's understand why are we using vernier caliper? What's the use of this? Why can't we only use meter scale, centimeter scale? Why can't we use linear scales? The main reason behind using these two instruments is about the least count, right? So right now I'm not talking about the least count of vernier caliper, but in general I'm talking about least count. Least count is the minimum measurement, is the least measurement that can be taken from an instrument, and when we are saying it can be taken, we mean to say that we can take it precisely with precision. It goes without saying that this is with this is an accurate measurement, right? So we won't be able to measure a length something like this. Let's suppose 7.567 centimeter using a linear scale. Using a linear scale, you can measure 7.5, or after that you can measure it as 8 centimeters. That means you can give your answers as precise, but it won't be accurate. These answers are not going to be accurate. If you want to give this as answer, that means the least count should be of that particular instrument should be 0.01 centimeter. So the reason why we are using vernier caliper and not your normal linear scale is that we can't actually compromise with readings, right? So 7.5 or 8.8 centimeter can be called as precise, but these are not accurate, whereas the actual reading is 7.567. The actual reading is going to be 7.567, right? So that's why we are going to use a screw gauge or vernier caliper. First, let's talk about screw gauge. In screw gauge, my dear friends, first of all, you have got a scale over here which looks like your linear scale, right? This thing is called as main scale. This is called as main scale. And then you have got two jaws connected over here, and these jaws we can slide it over main scale. And let's suppose we want to measure the width of a block. Let's suppose something like this. We want to measure the width of a block. So we'll keep it between the jaws, we'll close the jaws, and then first thing that we are going to do is we are going to read the main scale reading first. We are going to first read the main scale reading. So you guys can see here you have got 1 division, 2 division, 3 division, 4 division, 5 division, right? And then after this 5th division, we'll take the help of vernier scale, and then we'll use the vernier scale. It is quite similar to your usual scale, my dear friends. I'm going to also show you the usual scale. I believe I have got a ruler over here, right? Like for example as this one. Let's suppose we want to measure the length of this block. Clear? So first we can see, sir, we have got 0 length, 0 marking, then 1 marking, then 2 marking, then 3 marking, then 4 marking, then 5 marking, and in between of this 0 and 1 you have got 3 more divisions. So first of all, you are going to see this main scale. Your first idea is to see the main scale. So till main scale, we can see that this edge is between 2 and 3. So this is the role of this main scale. So similarly in this also, first we are going to look at the main scale. First is we are going to look at the main scale. Then when we are going to find out an accurate reading, more accurate reading, then we are going to look at the vernier scale. So when you are going to look over here, you are going to say, okay, this is first division and this is second division. Then we are going to find out what this divisions corresponds to. Clear? So now using the same thing over here, how we are going to use vernier caliper? Pay attention. First of all, we are going to find out the least count of vernier caliper. Least count of vernier caliper. Now I can make a separate video on instruments that simple video, then only one video on instrument will be of around minimum of around 40 minutes to 1 hour, right? It will take that much of time, in which we can have a, either we can have a simulation diagram, or we can have a working model where we can have a working vernier caliper in front of us. We can understand through that as well. But right now, let's first discuss some of the numericals linked with this particular topic. And for that, when we are going to talk about least count of VC, then we are going to say least count of VC is going to be 1 main scale division minus 1 vernier scale division. This is going to be the minimum measurement that we can take from a vernier caliper. This is going to be the formula. And along with this, they are going to say one or two information, like for example, as M main scale division coincides with N vernier scale division. Using this, we can say that this means that N vernier scale division is equals to M main scale division, which means that 1 vernier scale division will be equals to M divided by N main scale division. And if you are going to substitute this value back into this formula, finally our least count will look something like this: 1 main scale division minus M divided by N main scale division, or N minus M divided by N main scale division. Let me give you one example of this. Example is, my dear friends, something like this. Let's suppose they are saying a vernier caliper has 1 millimeter mark on the main scale. That means 1 main scale division is 1 millimeter. You have got 1 millimeter, then 2 millimeter, then 3 millimeter, then 4 millimeter, and so on, right? It has 20 equal divisions on the vernier scale which match with 16. So that means 20 VSD matches with 16 MSD. So from here, 1 VSD can be written as 16 divided by 20 MSD. Let's use it in the formula of least count, that is 1 main scale division minus 1 vernier scale division. So 1 MSD minus, instead of VSD, we are going to write 16 upon 20 MSD. So you can write it down as 20 minus 16, that is 4 by 20, which is 1 by 5 times of MSD, and MSD is 1 millimeter. So 1 by 5 is 0.2 millimeter. So this is going to be the least count. This is how we can find out least count. Very easy, very basic. But if you want to understand how this formula works, or why we are talking about least count formula is 1 main scale division minus 1 vernier scale division, then do let me know. I'll make up a separate video on just vernier caliper and screw gauge. Although if you have ever seen vernier caliper in your school, in your lab, then you can understand when you are going to close the jaws of the vernier caliper, then we are going to be only relied on the vernier scale, and then we are saying that what is 1 main scale division minus 1 vernier scale division. This is the least measurement that we can take from that, from a particular instrument. Correct? Clear? So moving on, then my dear friends, if we want to find out the reading of a vernier caliper, right, reading of a vernier caliper, then what we can do? If we want to find out the reading of a vernier caliper, then pay attention. First of all, right now we are not talking about zero error. So there is no zero error in a vernier caliper which has divisions of 0.05 centimeter on the main scale. So 1 main scale division, 1 MSD is equals to 1 MSD is equals to 0.05 centimeter. And 16 divisions on vernier scale, that means 16 VSD are equal to 12 divisions on main scale. So first of all, let's use this information. 1 VSD will be equals to 12 divided by 16 MSD, which means that least count will be equals to 1 MSD minus 1 VSD. You can be far quicker than this. This is just second problem, so I'm writing each step. So that means 1 MSD minus 12 by 16 MSD, which means that we'll get 4 by 16 or 1 by 4 of MSD, and MSD is 0.05 centimeter. Clear? Hopefully this is all done, and then you can solve it. And then let me explain you the reading of a vernier caliper. So reading of a vernier caliper is written something like this. This is your final reading. So as I have told you, first we will be talking about main scale reading. Got it? First we are going to talk about main scale reading, and then after main scale reading we will say main scale reading plus vernier scale division multiplied by least count. Right now we are not discussing any error. After this particular question we will be discussing that. Clear? Solve it, find that one out. It will become 0.025, right? 0.025, and then this will be something like this. Finally the reading will be main scale reading is 0.5 centimeter plus vernier scale division is 8 multiplied by 1 by 4 into 0.05, and this is also in centimeter. So whatever the final answer is, you can find out that as reading. Clear? But now let's discuss what do we mean by zero error. What do we mean by zero error? Clear? Any doubt? Any doubt till here? Done? Be quick. Come on. See, now when we are talking about zero error, let's suppose the jaws of the vernier calipers are completely touched, are completely closed, right? The jaws of the vernier calipers are completely closed, and see, please understand, this was the zero of the main scale, correct? And let's suppose the zero of the vernier scale is also coinciding with this. This basically signifies that there is nothing in between of it. So we are trying to match our answer from the reading with what we are observing. We are observing that there is nothing in between of these two jaws, and the vernier caliper is also giving reading as 0. The final reading is 0 centimeter. So that means when the 0 of main scale and 0 of vernier scale are coinciding, it means that, and when there is nothing in between of it, of course, then it has got no zero error. But what will happen if, let's suppose, you have connected the jaws, you have joined the two jaws, and the 0 of the vernier caliper is towards the right of the 0 of the main scale. Please understand. It means that right now there is nothing in between of these jaws. It should have given the value as 0. It should have given the reading as 0. But now what we are going to do is, because it is not actually coinciding with the 0, then we are going to find out the next coinciding division. So this is first, second, third, fourth. So you guys can see we are actually having first, second, third, fourth division is coinciding, right? Fourth division is coinciding. So when you are going to finally find the reading of this, when you want to find the reading of this, reading will be something like this, my dear friends. Pay attention. Reading is always main scale reading plus vernier scale division multiplied by least count. I'm not talking about, right now I'm not talking about zero error. Clear? Let's say we don't know the concept of zero error, we only know that this is how we are going to read. This is how we are going to find the reading. So what we are going to do is, we are going to say right now, the this zero, after this zero we are going to say first, second, third and fourth. So main scale reading is 0 plus fourth division multiplied by least count. So this is your reading, and in reality there is nothing in between of it. So that is why we are going to call it as positive error or positive zero error. When the zero of the vernier caliper is towards the right of the zero of the main scale, even when the jaws are perfectly joined. And in that case, the positive zero error is going to be this value. That means the coinciding division multiplied by least count, right? So positive zero error is n multiplied by the least count. So n is the coinciding division. Clear? And always remember, now we are going to write down the corrected reading, and now I'm going to use different page. The corrected reading will be, now let's suppose you have got some, you have opened this jaws, you have got some block over here, you want to measure the width of this block. Clear? You want to measure the width of this block. So you are going to write it down something like this. Correct reading will be main scale reading plus vernier scale division multiplied by least count. But now we know that this instrument has some error, so we are going to write down minus times of that positive zero error. Positive zero error. So in the next term, next line, we are going to write down main scale reading plus VSD multiplied by least count minus n multiplied by least count. This is going to be the correct way of writing it down. Always remember, we always subtract errors. We always subtract error, right? Don't get confused. Initially we were saying we always add errors. Here we are saying subtract errors because we are now trying to compensate it. Please understand, this instrument is always measuring some more value. It's like, let's suppose you know your weight is 70 kilogram, right? Let's suppose you know your weight is 70 kilogram. Actual weight is 70 kilogram and a particular weighing scale is always showing you 72 kilogram. And let's suppose your friend measures their weight and they say ki my weight is 62 kilogram. So you are going to say your actual weight is 64 kilogram. So what you are trying to do, you are compensating it, right? You are compensating it, that it is all hopefully you are getting it what I am trying to say. Let's suppose your actual weight is 70 kilogram and it is showing you 72 kilogram, and your friend says that my weight, this machine is showing 62 kilogram. So you are going to say your actual weight is 60 kilogram. You are compensating it, you are subtracting that error, right? So similarly over here as well, we are subtracting that error, correct? Now when we are going to talk about negative error, things are going to be slightly different. This is for negative error. Let me remove this. In negative error, my dear friends, the zero of the vernier scale will be towards the left of the main scale zero. So this is the zero of the main scale and this is the zero of the vernier scale. Now pay attention. See, what's going to happen is, the better way to understand is, when I'm going to actually open the jaws, I'll open it, and then at a particular time the zero of the vernier scale and zero of the main scale are going to coincide like this. And at that point there will be a slight space in between of this, in between of these two jaws, right? This vernier scale has moved in this direction, but at that point this vernier caliper is reading 0. At that point this vernier caliper is reading 0. Even when there is a space in between of these jaws, it is still reading 0. That's why it has got negative 0 error. But way of writing negative 0 error is slightly different. We are going to write down the total number of vernier scale division minus vernier division coinciding. So let's suppose there are total vernier scale divisions are, let's suppose 20, and vernier scale division that is coinciding is let's suppose 5. Got it? Let's suppose it is 5, or not 5, let's suppose it is 50. So the negative 0 error will be negative times of 20 minus 15 multiplied by least count. So that means minus 5 times of least count. And again, my dear friends, when you are going to write down the corrected reading, you are going to write it like main scale reading, fine, vernier scale division multiplied by least count, and again we are going to always subtract the error. Remember it. Let me now break it down for you. See, we have come up with this idea that we are going to always subtract the error and we are going to write down sign with error. So it will automatically adjust. With let's suppose your actual weight is 70 kilogram and a machine is saying, you know, your actual weight is 70 kilogram and a particular machine is saying 68. So that means now you know you need to add. In order to adjust it, you need to add. Clear? So that's what we are trying to do, but because we don't want to get confused, we are saying two things. We are going to always subtract the error and we are going to write down error with its sign. Clear? Now let's look at one example. By the way, solve this question quickly. Be quick. Find the answer for this one. Vernier caliper has main scale 10 centimeter equally divided into 200 equal parts. Alright. So that means one main scale division will be 10 centimeter divided by 200. Is it clear? Because in 10 centimeter you have got 200 equal parts. So for one main scale division it would be 10 centimeter divided by 200. Hopefully this is all clear. So this will actually become, dosto, 1 by 2 is 0.5. So this will become 0.05 centimeter. And then they are saying its vernier scale of 25 division coincides with 12 millimeter on main scale. So dosto, one main scale division is equals to 0.05 centimeter. Clear? 0.05 centimeter, or you can rewrite this thing as 0.5 millimeter. Done? So from here, my dear friends, you can get to know what 1 millimeter is. In 1 millimeter, you will have 1 upon 0.5 or 2 main scale division. So in 12 millimeters, you know, you can have 2 multiplied by 12. That means this is your 24 MSD. This is your 24 MSD. So they are saying 25 VSD is equals to 24 MSD. Done. This is a slightly different question. That's why I've explained it. And then again, you can find out the least count from 1 MSD minus 1 VSD. Pay attention and let me know if you have any doubt. Clear? Done? Is it cool? Be quick. Next, the main scale of a vernier caliper has n divisions per centimeter. This means that in 1 centimeter of vernier caliper you have got of one main scale, you have got n main scale division. So one main scale division will be 1 by n centimeter. Done. N divisions of vernier scale and n divisions of vernier scale coincides with n minus 1 divisions on main scale, which means that one vernier scale division will be equals to n minus 1 divided by n main scale division. Next is least count will be 1 main scale division minus 1 vernier scale division. Again 1 MSD, let's keep MSD as it is. So 1 MSD minus n minus 1 divided by n MSD. So it will become n minus minus plus and MSD. N gets cancels out. 1 upon n multiplied by 1 main scale division is, I believe, 1 by n. So answer will be 1 by n square centimeter. 1 by n square centimeter. Also find out the answer for the last problem, okay? Also find the answer for this problem. Clear? Any doubt? Quick. Let's also complete screw gauge. Now, screw gauge is also, we also use screw gauge in a similar manner. We have got two scales over here. One is your circular scale and one is your pitch scale, right? Or again, we can call it as linear scale. This thing can be also called as linear scale, and this is your circular scale. So it works like it is like a screw. That's why we are calling it as screw. When you are going to move it anti-clockwise, it will open, and when you are going to move it clockwise, it will get closed. It will get tightened up, and when you are going to tighten up, this will get height. I mean, it will start to get height, and then we can actually have any ball or anything which any material whose diameter we want to calculate, and then when this ball will be screwed, it will get tightened between these two screws and this stud. At that point, we are going to start to take our reading, and again we are going to start with the linear scale first, and after taking the reading on linear scale, we'll jump to our circular scale. Clear? Now see how it's work. First of all, we'll have to remember the formula of pitch of the screw. Pitch of the screw basically means distance moved by the screw divided by total number of rotations given, right? Total number of rotations given. Let's suppose we are saying that we have given 10 rotations. We have given 10 rotations, and the screw actually moves by 1 millimeter. Let's suppose. So that means in one rotation, it moves by 1 by 10, that is 0.1 millimeter. Clear? In one rotation, it will move by 0.1 millimeter. I'll tell you why we are trying to do this after calculating the least count. Now let's find out how many rotations are there total. How many rotations are there total? So we are going to say pitch divided by the total number of rotation. Pitch divided by the total number of rotation. This will be called as the least count of the screw gauge, and I'll tell you the reason behind it. Again, if you want to understand it in a more detailed manner, then I'll come up with a video on this, because in that I'll have to show you by simulation, but still you can understand it. And all the batch students remembers that in class we have talked about simulation videos, and I try to explain you how we can find out the least possible length, but here also you can understand it. See, what we are trying to do? We are basically trying to do that we have got something over here, and let's suppose now we are screwing it, right? We are turning it, and after, let's suppose 10 complete rotations, after 10 complete rotations, this moves by 10 millimeter. This moves by 10 millimeter. So what is the minimum number of rotation that you can give? That is 1. The minimum number of rotation is 1. So let's find out how much it will move in one rotation. That is known as pitch, right? That is known as pitch. So pitch is going to be 0.1 millimeter. Clear? Now, my dear friends, amongst, let's suppose there were 200 complete rotations possible, or 200, sorry, not rotation, 200 complete circular divisions were there in circular scale. In circular scale. Let me also rectify this. This is actually not rotation. These are also total number of circular scale division. Now pay attention. Let's suppose there are 200 circular scale divisions on the circular scale. So for one circular scale division, it will be 1 divided by 200. 1 divided by 200 of what? Pitch. So this is going to be your least count. So that is why we are saying least count will be pitch divided by the total number of circular divisions. Again, if you have any doubt, come back to this diagram. Here you have got circular divisions on this circular scale. This is how the circular divisions work. Clear? So let's suppose you have got total of 200 circular divisions. When we are rotating it 10 rotations, it was moving 10 millimeter, or 10 rotations it was moving 1 millimeter. So for one rotation it is moving 1 divided by 10 millimeter, and in one complete rotation, in this rotation we have got divisions. In one complete rotation, how many divisions are there? 200. So in one division, how much it will move? So pitch divided by total number of divisions. So this is going to be the minimum measurement that you can take out of this. That is why for least count we have got a formula something like this: pitch divided by number of circular scale divisions. Clear? Pitch divided by number of circular scale divisions. Let me give you one example for this. Let's suppose someone is saying if a screw moves 1 millimeter in 2 rotations, so that means in 2 rotations it moves 1 millimeter. So in one rotation, how much it will move? 1 divided by 2 millimeter. Now pay attention. I am not using formula. First, let's try to understand it. In one rotation, how many divisions are there? So let's suppose there are n circular scale divisions. So in one circular scale division, how much it will move? So it will move 1 upon 2 multiplied by n. This is going to be your least count. First we have got main scale. After that main scale you have got another scale. In this case you are calling it a circular scale, right? So this one circular scale division will be your least count. Clear? So instead of this, now one rotation is this, so this is now called as pitch, and least count is written as pitch divided by total number of circular scale division. So pitch comes out to be 0.5 millimeter whole divided by they are saying 500 divisions. So 500 divisions. So 2 points, and this gets cancelled. So answer is 0.001 millimeter. This is going to be the least count. And if you are going to solve this, you are going to get the same answer. Done? Let me know if least count concept is absolutely clear. Be quick. All cool? And this is how we are going to again take the reading of any Let me give you one question out of this. Let's see. Here they have said that pitch is 1 millimeter. Divisions are 100, which means that least count will be pitch divided by 100. That means least count is 0.01 millimeter. Then they are saying a student measures the diameter, he gets the main scale reading. So finally reading will be written something like this, friends. Finally it will be written as main scale reading plus circular scale division coinciding multiplied by least count, and we always subtract error. We always subtract error. So main scale reading is 5 millimeter, and then they are saying circular scale division is 25. So 25 multiplied by 0.01 minus, and then they are saying screw gauge has a positive zero error. We are going to talk about errors in this also, but positive zero error is 0.03. So 0.03, and it is in millimeter. This is also in millimeter, this is also in millimeter. So now we can, whatever this answer is, we can find out that. So this is going to be 5 plus 0.25 minus 0.03. Done. So what I am trying to say is that writing the final reading is quite same in both of vernier caliper and screw gauge. The only difference is in least count. But if you are going to closely understand, if you are going to pay attention, you can understand how we have derived this formula of least count. This is the minimum measurement, the least measurement that we can take. Clear? Now let me also explain error, and then we can end this session. My dear friends, if you have totally closed the screws, right? You have totally closed the screws, and the zero of the linear scale is coinciding with the zero of the main of the circular scale, then that means there is no zero error or non-zero error if it is coinciding. Correct? If let's suppose the zero of the circular scale division is below, see there are two ways of writing it. We are going to say that zero of the linear scale, zero of linear scale is above, or zero of circular scale is below. They are basically same thing. Clear? They are basically same thing. See why we are calling it as positive zero error. First try to understand this. What we are trying to do is, let's suppose we want to unscrew it, we want to open it, right? So what will happen when you want to open it? You will move it in anti-clockwise direction. So when you are going to move it in anti-clockwise direction, already right now it is actually giving you some value when there is nothing in between of it. How? Let me explain. In this diagram, by just looking at this diagram, if you want to write down the reading, you are going to write it like 0 main scale reading plus the 0 of the circular scale division is actually 10th, right? It is the coinciding division is 10th. So you are going to write 10 multiplied by the least count. So it is already giving some reading. Got it? It is already giving some reading. That's why it has got positive zero error. And again, we are going to, when we want to find out the corrected reading, we are going to write it like reading minus positive zero error. Reading minus positive zero error, and error will be written in the similar manner as we have done in vernier caliper. Got it? Sorted. Last point, negative zero error. In negative zero error, doston, the zero of the circular scale division will be above from linear scale, and then the number will be something like 90, and this will tell you that this is a negative zero error. And in this case, again, when you want to find out the negative zero error, this is actually not right. You are going to again write down the total number minus coinciding and with a negative sign multiplied by least count. So let's suppose total numbers are 100, total divisions are 100. So 100 minus 90 multiplied by least count. This is going to be your negative zero error. All right, so with this, now let's solve one or two more problems. Pitch is given. Pitch is 0.5 millimeter. There are 50 divisions on the circular scale. So n is 50. Using this, we can find out least count. Least count will be 0.5 mm divided by 50. Friends, this will become 1 and answer will be 0.01 mm. Hopefully now in least count you won't be having any doubt. Clear? Now let's write down the reading. In the measuring the thickness of a metal plate, there are 5 divisions on the pitch scale. 5 divisions on the pitch scale, and 34th division coincides with the reference line. Got it? All right, pay attention. I'm going to consider one main scale division over here as 0.1 mm by looking at the pitch. No, 0.5 mm, sorry. 0.5 mm. 0.5 mm. Although they have not said what one main scale division is, but fine, 0.5 mm. So finally the reading will be something like this. They are saying there are 5 divisions on the pitch scale. So 5 multiplied by 0.5 mm plus 34th division. So 34th multiplied by 0.01 millimeter. This is going to be your final answer. One MSD is missing in this, but fine, this is going to be the answer. Next, screw gauge least count is given. There are 50 divisions. Pitches they are asking, so you guys can do this. Is from NEET 2020, easy. So pitch is going to be least count multiplied by 50, so that's going to be 0.5, right? So that this is very, very simple. What about this one? This is from 2018. In this, they are saying diameter using a screw gauge of least count is given, main scale. Okay, fine. So finally the reading will be main scale reading, that is 5 millimeter plus 0 of the coincides with the 24 above. Okay, fine. If the screw gauge has a 0, fine. All right. So that means 25 times least count, that is 0.001 centimeter. Change the unit. Okay, let's write it as 0.5 mm, 0.5 centimeter, and then plus we always subtract, huh? So minus of 0.004 centimeter. This is going to be the answer, whatever this is. Clear? Whatever this is going to be the answer. Done. Kindly see. If you have any doubt, do let me know. Be quick. Sorted? Let me see if I can give you some questions in homework. By the way, I have attached some formula sheet along with these notes. We have completed almost each one of them, right? Power rule has been also completed. One more special points regarding error. So if number of observation is made n times, then the random error reduces to 1 by n. Kindly remember this point, right? It will reduce to 1 by n times. Solve this question in homework if you want, right? Very easy. And I have attached a answer sheet also over here of this, so you can check your answers, right? We need to find out fractional error in this. Other than this, we have almost completed everything. All right. So that will be all. Find the final answer for this, and then we are going to start basic maths in our next class. Okay, and in our next class also we are not going to start with trigonometry, and we are going to solve questions of all of those topics. But since we have completed those topics in last week on YouTube, I'm going to start with questions on trigonometry, questions on differentiation. I'll start explaining integration, and we are going to understand vectors in detail and questions also on that. Okay, so that will be all for today. Thank you so much, friends, and then let's meet in next class. Okay, bye bye.